Marine Gurukul has launched a number of online modules to support the students in passing their competency exams. For more details, you may connect with us and write to us on the email ID on the screen, that is marinegurukul@gmail.com. Thank you. Hello, welcome to Marine Gurukul video series. Based on a lot of requests received through WhatsApp and through comments on the channel, we are pleased to present this video on use of trim tables. What are trim tables? Trim tables provide rapid and reasonably acceptable drafts forward and aft after loading, discharging, or shifting of weights that are not too large. So the weights involved should not be too large, right? These tables are usually part of ship's stability booklet. The tables provide for change in draft forward and aft when tanks are filled to their 100% capacity and 100 tons of weight is loaded at different locations along the ship's length. Information is tabulated for different mean drafts of the ship. In case the table is not provided for the ship's mean draft at any point in time, the given tables are used with linear interpolation between the appropriate drafts. They can be used for shifting of weights as well, as shifting can be treated as discharging from one location and loading at the other location. Let us now have a look at the trim tables for the tanks of liquid on board the ships. Here is a sample table for MV Hinge ship whose stability booklet is often used, and we can see that we have all the tanks on the ship listed out here in column 1. These tables provide change in draft in centimeters when the tank is filled to its full capacity, that means 100% capacity, and how much will be the weight depending on the contents which are mentioned in column 2. The weight for 100% of the 100% capacity of the tank content is given in column 3. So the changes in the draft given here are for the weights which are mentioned in column 3. The table is entered with the name of the compartment in the first column out here and the mean draft of the ship in the upper part. Here we can see this draft, 7 meter mean draft and 9 meter mean draft and so on. For part filling or partial filling of the tanks or compartments, the change in draft obtained from these tables is used in the same ratio proportion. So if a tank is half filled, these values are made half. If it's 25% full, values are made 1/4. For removing the tank contents, that is discharging or consuming, same tables are used, only the sign plus minus is reversed. So if it is plus for loading, it becomes minus for discharging, and if it was minus for loading, it becomes plus for discharging. In some ships, such separate tables for tanks are not there. In such case, we can use the same tables as we are going to use and learn now for even for the tanks. So on your ship, if you don't find trim tables for the tanks, don't get worried. You can use the tables that will follow now even for the tanks. Let us now have a look at trim tables for loads anywhere along the ship length. Here is the sample table on display. These tables provide change in the draft in centimeters when 100 tons is loaded at different locations on the ship. That means the value of the change in draft that you will obtain from these tables now would be on assumption that only 100 tons of weight is loaded. The location is given in this sample table with distance of from midships. You can see this column first. Here it's 3 meters aft of midships, 6 meters aft of midships, 9 meters aft of midships. And the right half of the same page gives you 3 meters forward of midships, 6 meters forward of midships, and so on. So the location in this sample table is given with respect to midship and also with reference to the frame number. The next adjoining column is frame number. So you could identify the location either with the distance off from midships or with the frame number. When you use these tables on board your ship, please see what reference has been used for the distances. The mean draft for the sample table is 3 meters and it is given on top of the page. You can see this particular page is for a mean draft of 3 meters. That means this full page is for a mean draft of 3 meters. The table is entered on the appropriate page which corresponds to the mean draft of the ship and together with the location where the weight is loaded. If the weight happens to be less than 100 tons or more than 100 tons, the values for 100 tons can be adjusted by ratio proportion method. For discharging the weights, same tables are used, only the signs are reversed. Plus is made minus and minus is made plus. Shifting of weights can also be dealt with by the same tables because shifting can be considered as comprising of discharging from the old location and loading at the new location. Now we shall learn how to use the trim tables through an example. The question on display has been taken from Chief Mate Phase 1 MMD July 2014 examination. MV hinge ship floating at a draft of forward 5.45 meter, aft 6.53 meters, fills up number 1 dB tank with water ballast. Discharges 120 tons of cargo from number 2 tween deck, 99.5 meters forward of after perpendicular, and shifts 70 tons of parcel of cargo from number 2 tween deck to number 4 tween deck. Using trim tables, determine the final drafts forward and aft. Now to solve this question, if you like, you may follow or adopt this table. We have the compartment in the first column, name of the compartment. Then we have the location. In the question, it is given from after perpendicular, so it's subdivided into two. Our trim tables were from midships, so we'll convert that location given in the question with respect to after perpendicular to a location with respect to midships. Then the operation, that is loading or discharging, and then the change in drafts aft and forward, and of course the mean draft of the forward draft and the aft draft. The first thing we shall enter here is the initial drafts. Now these values 6.530 and 5.450 come straight from the question, and we get their mean as 5.990 and we round it off to 6 meters. Now you don't have to spend more time by taking the exact mean value. You can round it off to the nearest 0.5. So you can round off your drafts first to say, for example, 5 meters, 5.5 meters, 6 meters, 6.5 meters, and likewise. Then the first operation given is number 1 dB is ballasted to its full capacity. What will be the changes to the aft and forward drafts? We'll go to the trim table for the tanks. It has come on the display. Now here you see there are two entries for number 1 dB. In one we had water ballast, in the second one heavy fuel oil. So obviously in our case it's the water ballast. So this is the entry which will be applicable to us. Now our mean draft is 6 meters. The mean drafts here are 5 meters and 7 meters. So we shall interpolate between the two. For interpolation, you may use a format like this. Operation number 1 dB water ballast filled up, mean, change aft, change forward. So for 5 meters mean draft, you can see the aft draft is reduced by 18.3 centimeters and the forward draft is increased plus 31.8 centimeters. Likewise, we pick up the values for 7 meters from here and enter them in the table. But we want it for mean draft of 6 meters, which now comes here. For 6 meters, we interpolate between these two. The change in draft shall be minus 17.4 centimeters aft and plus 31 centimeters forward. We convert these changes to meters by dividing by 100 and we transfer them here. So the change in draft aft because of ballasting of 1 dB will be minus 0.174 and forward change will be plus 0.310. We apply them to the initial draft and we calculate something called as intermediate draft. And after this first operation, the intermediate drafts come to 6.356 and 5.760. We find the mean of these two. The mean comes to 6.058, which when rounded off again translates to 6 meters. Our next operation is 120 tons discharged from 2 twin deck from this location given in the question. So 99.5 meters forward comes from the question of the after perpendicular. But if you remember MV hinge trim tables, the locations are given with respect to midship. So we'll have to convert this and express it with respect to midships. We can use a simple line diagram. This line represents MV hinge forward and aft. Length between the perpendicular is 143.16 meters. Midships will be midway. So this length will be L by 2, that is 71.58 meters. Now the weight is discharged from a location 99.5 meters forward of after perpendicular. So that means it's forward of H. And by how much? Difference between 99.5 and 71.58. And that gives us that this 120 tons is discharged from a location 27.92 meters forward of midships, which converts to 28 meters forward. So this location from midships, we can round off to a whole meter. We don't have to take fractions of a meter. So 120 tons is discharged from here. Now if you remember, our trim tables were given for 5 meters and 7 meters, but our mean draft is 6 meters. So we shall again need interpolation. And those tables are given for what? 100 tons of loading. First, we shall pull out the values if in the given location in 2 twin deck 100 ton was loaded. For what mean draft? For 5 meters mean draft. Here is the page for 5 meters mean draft. You can see 5 meters mean draft on top here. We go to the location 28 meters forward, which will be between 27 and 30 meters here. We visually interpolate between these values and we find that the change in the after draft shall be minus 3.6 centimeters and change in the forward draft is plus 12.2 centimeters. Now we go to 7 meter table, 7 meter mean draft table, and here is the 7 meter mean draft table. Again, location is 28 meters forward of midships. We interpolate between these values to get it for 28 meters and the change comes to minus 3.2 centimeters aft and plus 11.9 centimeters forward. We need it for 6 meters mean draft and we get the values minus 3.4 centimeters aft plus 12.1 centimeters forward. Now please remember, these are the changes in the draft if 100 tons was loaded. In our case, we have loaded 100, we have discharged 120 tons. So firstly, to account for 120, these values will be multiplied by 1.2. It will become 120%. And to account for discharging, these signs would be reversed. This will become plus and this sign will become minus. So here for 120 tons discharge at 6 meters mean draft, we may minus 3.4 into 1.2. We put the value here and we change the sign from minus to plus. Exactly the same way, we change this sign and make it 1.2 times. It becomes minus 14.5 centimeters. So the change in drafts aft and forward when 120 tons is discharged from the given location will be plus 4.1 centimeters aft and minus 14.5 centimeters forward. These values are converted to meters and transferred here, and they become plus 0.041 aft and minus 0.145 forward. And we apply them to these intermediate drafts after the 1 dB was ballasted, and we get the next intermediate draft, and these values come to 6.397 and 5.615. We take the mean of these two. The mean comes to 6.006. When it is rounded off, it again becomes now 6 meters. So if you have any doubts, please pause the video, see how these values are obtained, and once you are satisfied, you may continue with the video. Our next operation is 70 tons shifted from 2 twin deck to 4 twin deck. And as explained earlier, this can be considered as if 70 tons is discharged from number 2 twin deck and loaded in number 4 twin deck. Now, unlike number 2 twin deck 120 tons discharged, whose location was given in the question, there is no such location given for this cargo which has been shifted. In the absence of such information in the question, we shall take the LCG of the compartment concerned from the capacity table. Here is the capacity table of MV Hinship, in which we see here number 2 twin deck, its LCG is out here. The LCG of number 2 twin deck from the capacity table is 103.91 meters. So obviously it's from after perpendicular, it's written here, from after perpendicular. And LCG of number 4 twin deck is here, and that is given as 57.44 meters. And as we did in the case of 2 twin deck earlier 120 ton discharge, we'll convert this location with respect to midships. So we again go back to the same line concept, and now this one was discharged from 103.91 meters. That means a location forward of H equal to the difference between the values. This becomes 32.33 meters, which is equal to 32 meters forward, 32 meters forward of midships. And this one is discharged from 57 meters, so something aft. How much? 14.14 meters, equivalent to 14 meters aft of midships. So now we know that the shifting can be considered as if 70 tons is discharged from a location 32 meters forward of midships, and 70 tons is loaded at a location 14 meters aft of midships. Now we shall find out the change in draft forward and aft when 70 tons is discharged from a location 32 meters forward of midships, vessel having a mean draft of 6 meters. Obviously, our trim tables are for 5 meters mean draft and 7 meters mean draft. We shall interpolate the way we did it for earlier discharge of 120 tons from 2 twin deck. Now, our tables will first give us if 100 tons was loaded at the given location of 32 meters forward of midships. And we'll use it for 5 meters. Here is the trim table for 5 meters mean draft. We go to the location of 32 meters forward. It's here on the screen between 30 and 33. We interpolate here mentally and just put down the values here. So the change in draft when 100 tons is loaded 32 meters forward of midships, draft aft shall change by minus 4.8 centimeters and the forward one will change by plus 13.4 centimeters. Next we go to 7 meters mean draft trim table and we again go to the location of 32 meters forward and we obtain that the aft draft shall reduce by 4.2 centimeters and the forward draft will increase by 13.0 centimeters. Interpolating between these two values here, we'll get the change for 6 meters mean draft. It is minus 4.5 meters aft and plus 13.2 centimeters forward. Now this changes if 100 tons was loaded in the given location. In our case, the weight is only 70 tons. So these values have to be 70% of what you see. So we'll multiply them by 0.7. And secondly, in our case, it's discharge. So we shall be reversing these signs. So obviously when 70 tons is discharged from this location, aft draft will change by plus 3.2 centimeters and forward draft will change by minus 9.2 centimeters. And these changes are now transferred here after converting into meters. So aft draft changes by plus 0.032 meters and forward draft decreases by minus 0.092 meters. And now to complete the shifting process, the 70 tons which has now been discharged from 2 twin deck is now loaded in 4 twin deck. So that means now we have to find the change in draft if 70 tons was loaded at a location 14 meters aft of midships and ship has a mean draft of 6 meters. So again interpolate between mean draft of 5 meters and 7 meters. So we have it out here. Initially we'll get it for if in number 4 twin deck given location 100 tons was loaded. 5 meters, we have the table here. We go to a location of 14 meters aft. Now 14 meters aft is here between 12 meters aft and 15 meters aft. And we get the values from here. We have already learnt it how to get these values. The aft draft shall change by plus 9.3 centimeters. Forward shall change by minus 0.1 centimeters. We go to 7 meter mean draft table. Out here now we have go to the same location of 14 meters aft and we interpolate between these values and we get the aft draft changing by the aft draft changing by plus 8.3 centimeters and the forward draft changing by 0.5 meters plus. We interpolate between 5 and 7 meters mean draft to get the values for 6 meters. The aft draft changes by plus 8.8 centimeters. Forward draft changes by plus 0.2 centimeters. In our case, it is not 100 tons that is loaded, it's only 70 tons. So these values will be multiplied by 0.7 to get for 70 tons. The sign shall be retained because it is loading. So when 70 tons is loaded in the given location of 14 meters aft of midships at a mean draft of 6 meters, the aft draft shall change by plus 6.2 centimeters and the forward draft shall change by plus 0.1 centimeter. These values after converting to meters are transferred here. So in the table, the aft draft changes by plus 0.062 meters and forward draft changes by plus 0.001 meters. Now having allowed for all the operations, ballasting of number 1 dB, discharge of 120 tons from number 2 twin deck, and shifting of 70 tons from 2 twin deck to 4 twin deck, we now can get the final drafts after allowing the changes because of shifting to the intermediate draft preceding it. So that means these will give us the final drafts here. Draft aft is 6.491 meters. Draft forward is 5.524 meters. The final drafts obtained by use of trim tables. Draft forward 5.524 meters. Draft aft 6.491 meters. I hope you have understood this example well, and through this example, even you'll have now a better understanding of what trim tables are. Now we come to end of this video. Hope you find it useful. The video serves the purpose for which it is made. Thank you so much for watching Marine Gurukul video series. Please share your comments, share the video with your friends, subscribe to the channel if already not done. Also press the notification button. Wish you all happy learning. Thank you very much.